Page 168. Oxy Acetylene Welding. It is a process of welding metal together by using heat from mixture between fuel gas and oxygen, which cause melting like puddle. When metal is melted, becomes small puddles and combines to a paddle. Then, two pieces of metal will be attached to each other, which may need electrode or may not, as shown in figure. Fuel gas that can combine with oxygen gas after flaming, it will cause high heat. There are several types of them, and each type has different temperature. Page 169. Gas welding technique. 1. Moving tip. For welding very thick workpiece, deeply melt welding path and wide welding path, the following techniques of moving tip and welding is required as shown in figures. Direction of welding. Center of welding path. Moving of tip. Direction of welding. Center of welding path. Moving of tip. Direction of welding. Center of welding path. Moving of tip. Page 170. Direction of welding. There are two types of gas welding moving direction as follows. 1. Forehand welding is suitable for welding workpiece which thickness is less than 3 millimeters. Because welding path can be strong enough and can weld very fast, and welding path can be well controlled without chipping off workpiece. Holding torch with right hand, start welding from right to left, and hold electrode with left hand. Torch should be leaned with workpiece at angle of 30 to 45 degrees. Flame will direct a junction of workpieces and also swing back and forth. During the welding, if you need more heat, the torch should be more upright. And if you need to reduce heat, then lean angle of torch and workpiece should be decreased. The directions of welding are shown in figure. Page 171. 2. Backhand welding is used for workpiece which thickness is more than 3 millimeters. Welding path will be melted deeply to bottom, making strong welding harder than thin workpiece. So this direction of welding can make workpiece receive more heat without blocking from electrode. Puddle for this direction is wider and deeper until bottom to make welding path melt deeply and completely. Right hand torch holder start to weld from left to right. The position and angle of torch are close to forehand welding and also the angle of tip. If the workpiece is very thick, the angle of tip should be in the direction of workpiece as shown in figure. Page 172. 2. Flat position welding is commonly used to position in welding two metals together. The edges of both workpiece must be dressed to attach to each other for welding in between both edges to be a welding path. The edge preparation of workpiece must consider the types of welding and thickness of workpiece as main consideration. If workpiece is not too thick, beveling is not necessary because normal welding can make the joint strong enough. For welding without beveling, workpiece must be appropriate distance to each other. Normally, the distance for each other should be equal to the thickness of workpiece and have to reserve some distance for the edges of workpiece correctly. The joint that is the highest of path must be placed far from starting point, a little to allow the expanding of workpiece in case of heat. Another purpose of this space is to make key hold while the joint of workpiece melts, which cause a complete deep melt. The preparation of this is shown in figure. Page 173. Welding metal for thin sheet workpiece is difficult to weld because while starting from one side to another side, edge of starting will get hot and melt, but another side is still not hot enough. When the heat for both sides is not equal, the expansion and contraction will not be equal. This makes part of workpiece that not weld start to bend apart or expand to lap each other and cannot continue welding. So tack welding is used to prevent the result from the above result. Tack welding procedures are shown in figure. When tacking welding has done to have appropriate space of joint, using the neutral flame and hold the torch with an angle of 45 to 70 degrees of workpiece surface. The inner flame is far from workpiece a little and then starts to burn workpiece at the right until get a puddle and insert electrode into that puddle until the puddle is filled over appropriately with workpiece. After that, move torch to the left and make little swing continuously along welding path. Electrode must be feed into the puddle all the time and related to the moving of torch. The main important is to keep the constant temperature and electrode inserting. Then we will get the welding path as required as shown in figure. If the material is thicker than 3 mm, forehand welding is used. Page 174. 3. Horizontal welding technique is the welding that welding path is parallel to the floor and welding path is at the side of workpiece or may tilt up or down a little. Holding torch and electrode is similar to flat position, but the angle of torch tip must be up a little depending on thickness of workpiece to use the force of flame to support the melted metal, avoiding from flowing down. Horizontal welding may be done the same method of forehand welding or backhand welding. This type of welding is shown in figure. Puddle of horizontal welding should be control not too wide because wide puddle will cause the melt metals flow and making overlap and upper edge will be undercut. Page 175. 4. Vertical welding technique is the welding that welding path is parallel to the floor and welding path is at the side of workpiece or may tilt up or down a little. Holding torch and electrode is similar to flat position, but the angle of torch tip must be up a little depending on thickness of workpiece to use the force of flame to support the melted metal, avoiding flowing down. Horizontal welding may be done the same method of forehand welding or backhand welding. This type of welding is shown in figure. Upward position welding. During welding, the angle of torch should be up about 5 to 15 degrees depending on thickness of workpiece. If thickness of workpiece is less than 3 mm, forehand welding should be used. If thickness is larger than 3 mm, backhand welding should be used. Downward position welding. This position is not commonly used because there is no support for melt metal and melt metal will flow downwards. This position may be used to weld workpiece which is not too thick and has small welding path. Moving tip must be done faster than upward position. This welding is shown in figure. Page 176. 5. Overhead position welding technique. In this position, operator must be patient. During welding, operator must be careful for the flame that heat the workpiece and the flakes that may blow to the operator. In the same time, operator must be careful for inserting electrode to the puddle. This position welding must use the technique that using the flame from torch to support melt metal to avoid flowing down. The workpiece for this welding position is placed above the head of operator. During welding, angle of torch tip should be at 70 to 80 degrees with below workpiece as shown in the figure. Page 177. 6. T-flat position welding is the technique to weld two workpieces that perpendicular to each other by using the edge of a workpiece placed on top of another in the position of T downward. The thickness of two workpieces may be the same or whatever. This welding, both of workpiece, will be joined by tack welding, first in perpendicular to each other. Placing two workpieces must be tilted 45 degrees with the floor. The angle of torch tip should be 80 degrees, with second workpiece to get more heat from flame more than first workpiece because the first workpiece will get overheat. The angle of torch tip should be tilted 45 degrees in welding path as shown in figure. During moving the electrode, the torch tip should be moved to the edge of welding path at the left and right a little to make welding path melt to electrode and make completely deep melt. Page 178. 7. T horizontal position welding technique is the welding that a workpiece lay on the floor and another placed perpendicularly on it. During moving torch tip, angle should be more than 45 degrees with bottom workpiece because the workpiece can emit heat faster than upper workpiece. If this angle is less than 45 degrees, the vertical workpiece may get heat too much and workpiece may be melted through. During welding from right to left and move it slowly and evenly. Flame must direct to the angle between both workpiece to heat workpiece until it melts, then insert electrode by leaving tip of electrode touch at the paddle softly. After that, flame is used to burn tip of electrode to combine to the puddle of workpiece. The welding path may be bulge, straight, or curve in, but there is only one welding path, no repeating. During welding, operator should not rest frequently because it will make welding path uneven. Moreover, welding path must be melted deeply to inside of the corner, not to the surface of both workpiece, which will make empty space in the middle. Page 179. 8. T vertical position welding. Upward welding is commonly used in gas welding because downward welding is difficult to control melted metal. Upward welding, torch must be in angle of bottom workpiece more than 45 degrees. Page 180. 9. T overhead position welding. The angle of torch tip is same as T horizontal position welding, but overhead position workpiece is high upper like T shape and welding path will be under the workpiece. This position is the most difficult position welding. Hand-over operator must flip upward and can cause fatigue easier than other welding position. During welding, must swing torch to left and right a little to make perfect welding path and insert electrode simultaneously. Page 181. Cutting metal using gas. Cutting metal using gas is cutting metal using flame from cutting head, which is from mixture of oxygen gas and fuel gas, and then burn the workpiece and cause oxidation reaction rapidly. In the same time, workpiece is sprayed by oxygen gas until workpiece is cut as shown in figure. Fuel gas is heated before cutting by oxygen. There are many types of gas, but generally acetylene is commonly used because it can give high temperature and easy to buy. Equipment used for cutting metal using gas are the same as gas welding, but tip is replaced by cutting head instead. Pressure regulators. Reverse flow check valves. Welding or brazing tip. Cutting head. Torch body. Gas hoses. Oxygen cylinder, acetylene cylinder, safety chain.